So here we are on the test bench. I've got a transfer case I built up last year. That's been running for about half an hour. I didn't realise how hot they get. They don't have to get warm. So what I've got is I've got a few experiments lined up, but it isn't finished. Let's get this straight. It is not finished. Why? Well, I've been sort of playing around with this little adjuster here. This is off a, chop saw bench. But it's got a slip nut in here. I'd rather have a permanent nut so I can wind that belt up and down till my heart's content and put some load on it. Now, I've put a strap round the thing here thinking it was going to fall off, but it wouldn't. You know, because the design's got like a tray. We can just drop the transfer case on and then bolt the front piece on with all the gubbins in here. Now, so what have I found that's a bit of a problem? I think it's the bearings. Now I've got this so they can just pop the belt off straight away, but when I turn this, it's beautiful. There's no backlash, there's nothing. It's lovely. You can't hear it, can you? But I think this bearing's a problem. It took a little while to set up, I must admit. Hence all the vice grips and ball grips all over the place on it. So the thing is, I don't know what I'm looking at. How hot should it be? What should it sound like? It's not the sort of thing you look for, is it? But if I can correct a problem, if it's really banging and clattering, then we can find it out. Now, I noticed on Ashcrofts, they only test them for about 5 seconds and that's it. I think they just do it on assembly oil, but these are full of proper oil and they've been running. So what we're going to do now, we're going to do a few experiments with tachometer to see what the difference in the speeds are. We're also going to dig out the temperature with the thermal imaging. We're going to take some pictures of it. That'd be interesting, wouldn't it? Because I want to find out what the difference is with these transfer boxes that have got those what do we call them? Those finned sumps on. I've got one down here. Now the setup there allows us to, here just to change this bottom part and make a different stand. Now I was going to make one out of metal and I thought to myself, well, I've only got 2 transfer boxes to test, so I'll probably knock one up out of wood and then screw it together. But this is a metal frame. I'll be using that a lot and it's screwed down to the bench. The bench is a bit sort of flimsy, I must admit, but it's there, and it's got a nice sort of space at this end to put a gearbox on and also tools and equipment to fanny about with. And your sandwiches, perhaps. So, less of the shenanigans. Let's see if it starts. Now, I'm going to start it on a slack belt. Alright, this is what I wanted. So this is, there you go. Now you can see the motor makes a noise. Now this is a problem because it picks up. I thought you wouldn't be able to hear the motor running very well through the box, but it does. It travels through the bench and up around the air and everywhere. So you can see what my idea was. You can see the belt's running really slow, but the box is driving through the friction of the oil and stuff like that. So let's get some revs going. Now instantly you'll be able to hear this bearing here is making a hell of a racket. Also the drive flanges with the bolts in rattle away like crazy. That's what they don't tell you. But it works. It works. Now I'm going to do a little experiment. Like that. See, that was my clutch. I'm going to do a little experiment. I've got the stethoscope out here, and I'm going to move the camera a bit further forwards, and I'll try and put the outputs as close as I can to the camera. Now, I'm not sure if that's going to work, but let's have a go. We've got nothing to lose, haven't we? Apart from a couple of fingers. Right. I'll turn these this way because I have no way of, you know, like doing sound through a computer anyway. So that's it. Let's go. rear look. It sounds like somebody's got a jackhammer banging it away. So, but it does work, you know, it does work. I mean, like I say, Mr. Treverthick with his first steam engine, must have had a few hiccups. So that's good. Let's check out some speeds with the old piles. Right, so the engine, the speed. 1732 RPM, 1732 RPM. Now, on the other gear, going in, let's have a look at the flanges just out the front. I got it wrong because I'm not showing off with that, it's just so bloody noisy. 436 RPM on the shaft because I put a chalk mark on this end of the flange. On the front one I did it on this end to experiment with. I wish I had the speedo here so we could play around with that. But what I've got to do now, I know it's noisy, it's rumbly, but again it's these bloody bearings. But what I'll do is I'm going to leave it running. I've got to change light bulbs on my Yaris. One of the bloody headlamps have gone. So now, of course, you have to take the whole plastic front off to get the bloody headlamps. That might take me an half an hour. So I'll leave this running and then we'll check its temperature. Now, let's go back. I just thought I'd tell you something here. Let's turn that off. So, these bearing blocks here are what's called self-aligning bearings. They're allowed to move a little bit in the housing, so if you cock it up, well, it's not the end of the world. Now I've got two in there, I've got two bearings, because I wanted to put the weight of the pulley belt when it's pushing down like this, when it's got the motor on it, to be supported by this housing here that I made, not on the shaft. The shaft can be driven that way, but not that way. So I thought that was a good idea, but now listening to it and playing around with it, maybe if I just go downtown and buy a really good quality SKF bearing, which is about $60, like I said, these are only $12, so what do you expect? But just mount it on the front bearing. Don't put the back one on, just mount the front one. I don't know, maybe. But then again, when we finish this experiment, I'm going to take the box off, leave the panel on the front and just drive it on its own, just drive the shaft on its own and see what happens. I'm very pleased with this setup so far, I must admit, because it is sort of warm to the touch, but there's no leaks. So if you were going to see a leak, you'd have seen it by now. The breathers, that's confidence. I've still got a bung in the breather, so I mean, that should have forced oil out all over the place, but it's okay. The diff lock works, that's nice. The high and low works. But like I say, let me go and change my bulb in my Yaris, get this running. It's now almost 20 to 3 on the afternoon, and we'll leave it running for a bit. And some of you who do mathematics will be able to work out how many miles we've done since then. Back in a bit. So it's been about half an hour. How hot has it got? Well, let's have a see. Right. So, I've already had a quick Scoobies at this and had a look with the thermal imaging. This is really interesting because you remember when I said that front bearing was noisy? Well, I already greased it up, just thinking it was dry, but it must be knackered because when I look at the thermal imaging of that bearing, where is the picture of it? Oh, that's it. It's 55 degrees. 55 degrees. The ambient temperature in here on the floor is 13 degrees. The second bearing on the inside, that's 68 degrees. How hot is the box? Well, this is the strangest thing. At the top it's 42 degrees. At the top of the sump here it's 39. If we go around the back, we get right down to the very bottom of the sump type area here. Let's come back a bit. We've got 36 degrees at the bottom. On the rear output we've got 44. Oh, wait a minute, it's calibrating. Yeah, we've got 44. And on the front we've got 41. But at the very top here we've got around about 44. But those bearings are really hot. That's pretty fun. The thing about it was, when I was running it, you can hear the sound all the way through the metal. If you use the stethoscope here, you can hear it rattling all through the steel frame. So maybe it's not a good idea. I don't know. Now, out of curiosity, whilst we're experimenting, maybe, oh, wait a minute, what if I run it with a partially slack belt, so it's, you know, it's slipping a little bit, you know what I mean? Because like I say, when it's on its own, it's great. It's just when you get some load on it and some speed, it must have sort of gravel in bearings. The motor doesn't make much of a noise. If I turn the motor on its own, it's not too bad. Oh, here's an experiment. Now I might call myself a liar on this one, but will it start in direct load? Will it be detrimental to the gearbox? I don't know. Let's have a try. Slow that down. Put the belt on. We'll drop this funky gizmo down. Right, now I'm going to move all my camera and out of the way, and everything out of the way, just in case the bloody thing falls over. Because I don't know, I haven't done this. Notice I took the cord off the FLIR thermal imaging camera just in case it got caught. So here we go, will it fall over? Oh, but it sounds bad, doesn't it? It sounds worse than before. Now that's with the belt slack. And the belts are in line, by the way. Just makes a racket. Just makes a racket. And you can see how hot it's got because the oil's just spewing out. So if it's 40 degrees here, how come it's 60 or nearly 55, 60 degrees on the shaft? Where's it getting its heat from? It must be from the bearings, it has to be. So this is the next day. The experiment driving with the belt was a complete failure. So I'm going to put the steering wheel back on the proper side instead of center steering. I did test the LT230 with the high gears in and the high capacity sump, and I ran it for half an hour, but the noise was just absolutely excruciating. The bearings got up to about 90 degrees Celsius. There was oil flying out of them all over the place, so I just abandoned that. So what I intend to do is to drive them using a direct shaft with these universal joints. Now it's going to take a little bit more setting up. I only hope that JP's free on his milling machine to put a new keyway in the shaft, because the shaft that was going through the bearings now is going to be too long, and the last thing I want is like vibration going through that box. So the closer I can get the universal joints to the motor and to the transfer case, the better. So it just means rearranging a few things. I mean, I did waste a bit of time and stuff like that, but I did run this LT230 and flush it out. But there was a little issue of something I couldn't figure out. Just let me stop here and I'll reposition the camera. Now this might be an ideal opportunity to have a look inside an LT230 from the underside. What was happening? Well, when I took it off the test bench, I heard this. And I thought, what the heck's that coming from? You know, look at all that movement. But what I didn't realise was the diff lock and the high and low selector wasn't gone into high range. All it needed to do was do that, and it's nice and tight. But it just goes to show you what, you know, this is what that lever, that linkage does, but it wasn't quite in place. It was just, I don't know how he'd managed to get there. Maybe it's because of these fine teeth, I don't know, but you know, it works, but for some reason it wasn't quite there. But now, if you turn this, it's beautiful, because originally I thought it might have been my settings for this intermediate shaft was wrong, but I was mistaken. So I'm going to put this back on. All the teeth mesh up right. Oh, one thing I wanted to tell you while I was here. You see the difference in tooth thickness here? So the main input gear is down here. You can't see that. You have to believe me, it's there. So your input shaft comes in here, drives this gear, which then drives this solid gear here and here. This is your high range, this is your low range. Now once upon a time I sold a transfer box many years ago to a chap in Canada, and he was an ex-military man and he knew everything. And he took the cover off and inspected it once he got it, and he said, those gears are worn. Those gears are worn. Look at those. Low gears, absolutely worn. It's been driven in low gear all the time. And I said, well no, that's how they are. And they are. Look, see? Thin, they're very thin at the crown of the tooth, whereas this one's kind of thick. This one's a little bit thinner, it's not quite the same, but I just thought I'd tell you that. Right, so there you go. Sometimes experiments fail. It worked great on paper, but it didn't really work in practice. Hey, at least you don't have to do it. So that worked, but I think the shaft type of thing will work. I just have to hope that JP's free today with his milling machine to do that keyway, and then we can get on with that, because that's not going to take a great deal of setting up. So this one with the fin sump is good to go. I've got another one to test, and hopefully with the new experiment, the shaft, I should be able to do a better test with the sound meter and everything, because I was picking up so much sound on that job, it was unbelievable. You know, if you thought it was loud on video, you should have heard it in here. Right, this is it. I'm going to wrap it up. See you later.